Here's our first example for the ambiguous case. We're going to do 3 total. We have to determine, before we figure out what the missing sides and angles are, is this going to be 0, 1, or 2 triangles possible in this case? So I've drawn out the triangle, as you can see here, being careful to set it up the same every time. So what I've got right now is an angle and 2 sides, making it the SSA case, 2 sides, 2 sides and 1 angle. So I set that up, and I always like to put the angle in the lower left-hand corner. That's big B, and in this case we have little b directly across from it, so that's why I have the 17 right there. Now the 15 can go either here or here, but I've always chosen to put it right here just so that I have the same setup each and every time. And then that just means if this is little c, this big C, and then the only pair that's left is big A, little a. My goal is to find those 3 missing pieces, the angles and the one side. I do need to figure out which one it is first. Is it 0, 1, or 2 triangles? And so to do that, I figure out the height and determine if this side right here is kind of on a hinge. If this one's swinging down, then does it actually touch the base of my triangle right here? I find that out by noting that this H, the H I can find by trigonometry, thinking about this as a right triangle in here. So I do sine of 82 equals H over 15. I multiply both sides by 15 to get this calculation, and it equals about 14.85. So what that tells me is that the 17 is long enough to touch down on the base of this triangle. Now once I figure that out, once I know, okay, that it's at least 1 triangle, then I have to figure out, is it now going to be 2 triangles possible? Well, I still think about that hinge, and having this 17 go over this way, is that 17 going to touch somewhere over on this side of the base? And here, since the 17 is larger than the 15, it's not going to work. So this one's not going to be 2 triangles, it's going to be 1 triangle possible, which is good news for us because that makes the problem a little bit shorter. Now when I'm trying to find these things, I have to find the angles and a missing side. The best way to do that here is to go for the angles first. We're going to make sure that we use the pair that we have. That pair that we have is the big B and the little b, so the 17 and the 82 degrees. Now I'm going to take that as one of my fractions, sine of 82 over 17, and you'll notice that I've put the angle on top this time, and that's just because I want to make my algebra a little bit easier. I'm going to try to find angle C because I have little c with it, so I'm going to do angle C, sine of angle C over little c, which is 15. So now I've got my proportions set up, and I can solve for the angle big C. Now first thing I would do with that is I would just cross multiply, and so that would be setting up my equation as 17 sine C equals 15 sine 82. And then I want to isolate C if at all possible, so I'm just going to divide by 17 and make this sine of big C equals 15 sine 82 over 17. Now I'm going to work with my calculator here. One thing that's really important to note is that your calculator does need to be in degree mode. I've got mine in degree mode, and so I'm going to then calculate this side of the equation. So that's going to be 15 sine of 82. I'll hit enter, and then I'll divide that by 17 to get a value for the right-hand side. So I would say here that sine of C equals about 0.8737. Oops, 38. All right, so now that I have that, I'm going to find out what angle C is, and that's going to be done by taking the inverse sine. So inverse sine, I'm just going to use the answer stored on my calculator already, and that equals about, we'll just round it to 1 decimal place. That means that big C is about 60.9 degrees. So I have one of my important pieces taken care of now. So I've got the big C. The other thing that I need here, well, before anything else, probably the next easiest thing is just to find the other angle, because if you'll notice, I've got 82 degrees. Now I've got 60.9 degrees, and so like before, triangles add up to 180, so I can just jump to the fact that if I subtract those, now the other remaining angle, A, is going to be 37.1 degrees. So I've got two of my pieces that I need right now. I just need to find the last piece, and that is little a. So little a here, I've got big A. Now I can go back and use my law of sines again. This time I'm going to put the A on the top just to make the algebra a little easier. And so then we'll put that over sine of 37.1 because that's what we found for big A. Set that equal to the original fraction that we had. I'm going to flip it though again. So I'm going to put 17 over sine of 82 because that is big B, little b. Now I can cross multiply, solve. Again, I'm going to hide the algebra in this case, but little a is going to be about 10.35, and that's my last missing piece for this example.